empty glass, a piece of cardboard with two arrows pointing in the same direction, and some water. Place the empty glass in front of the cardboard in such a way that you're still able to see the arrows through the glass. Now, slowly pour water into the glass and watch as the arrows change direction. You've just witnessed the reversing arrow illusion. Exactly how did this happen? This neat trick is due to two concepts, refraction and the emulation of a magnifying glass. When light passes through an object, it bends. In this experiment, light has traveled through air, the glass, the water, the back of the glass, and the air again. The filled glass works like a magnifying glass. As light passes through, it bends toward the center, which is the focal point. As it goes past it, the rays pass through each other, and what used to be on the left is now on the right, and vice versa. Voila! Number 9. Water that defies gravity. Gravity is a fundamental force that brings everything down to the ground. Today, we will attempt to defy it with anti-gravity water. The materials you need are a handkerchief, a wine glass, a bowl, and water. Start by draping the handkerchief over the glass, and then push the center of the hanky down into the glass. Fill the glass 3/4 full by pouring water into the middle. Gently pull the sides of the hanky down and grip the ends at the bottom of the glass, stretching it across the glass's surface. Flip the glass over the bowl as there may be a few drops of water. Gently pull the flaps down and look! The water doesn't flow into the bowl. Despite how I described the trick, I didn't really bypass the laws of gravity. Instead, the trick used a different concept called surface tension. The holes in the handkerchief became very small when it was stretched tightly, and then the water molecules began to bond with each other, creating a thin membrane that prevented it from seeping through. Number 8. Superheated water that doesn't boil. Everybody knows that when water reaches a certain temperature, it should boil, right? In this trick, we'll show you that it doesn't always happen. Here's what you'll need. Get a microwavable clear container, water, the microwave, a cloth, a pen, and a steady hand. Half fill the container with water, and then heat it in the microwave until it's expected to boil. You'll notice that it doesn't boil at all. Protect your eyes and hands as you bring it out using a cloth covering the mouth of the container, and be careful not to make any sudden movements. Now, drop an item like a coin or pen into the container. Poof! It suddenly boils. What just happened? This is called superheating. Microwaved water is undisturbed during the heating process, thus it doesn't form bubbles. Similar to the previous example, surface tension prevents movements of the water molecules, that is, until intervention occurs, such as dropping an object into the liquid. That's the only time it will boil. Magic? No, science. Number 7. Liquid movements. Here are 2 tricks you can do. Both tricks will need small identical glasses and a card. For the first trick, fill one with hot tap water mixed with red but preferably yellow food coloring. The second one should be cold water with blue food coloring. Cover it with an index card and tap the card gently to form a sort of seal. Then, tip it upside down and position it above the hot water glass. Slowly pull the card just enough to create a small opening between the two. Sit back and watch the trick unfold as the colors mix. If you enjoyed that one, then try this second trick. You'll have to use colored water and a lighter liquid, such as whiskey. Cover the glass with water with a card, and then put it on top of the whiskey glass. Gently pull the card to create a small opening, and this time they change places. The colored water goes to the bottom, and the whiskey goes up. They may be using different liquids, but the principle is the same. Weight. The molecules in hot water move faster, and as thus it's lighter than cold water. That's how it forced its way upwards and made the colors mix. In the second experiment, water is heavier than whiskey. That's how they swapped positions. Number 6. The plastic bag and balloons that don't leak. I think it's time that we moved on from glasses. For these next 2 tricks, I will be using plastic and rubber with water. The first one requires a sealable plastic bag, some water, and sharpened pencils. Fill the bag halfway with water and then seal it well. Poke a pencil into it and all the way through the other side. Feel free to add more pencils if you like. You expect it to burst, right? But it didn't. The reason for this is because the plastic is made of polymers, which allows it to change shape. When you poked through it, the molecules hugged the pencil, creating a watertight seal which prevented it from leaking. For this second trick, we'll be making a fireproof balloon. If you just burn an inflated balloon, it will pop, just like this. But with water, that all changes. Half fill the balloon with water. Now for the test. Hold a lighter under it, and lo and behold, it won't pop. Amazing, right? The reason for this is because of the water itself. The water absorbs heat, thus the rubber doesn't get as hot and can withstand the flame for longer. Number 5.